All right, thank you. Happy to be here again. This time I will talk about a little bit of the enablers that we use to deploy mobile private networks and how we see this, and also where they fit into the different solutions that we are deploying. If we start with mobile private networks, the way that I will present it here and the way that we take a pitch on it is it's for a dedicated function at a single company for a use case. So it's not sort of covering the aspect of slicing out of a public network. These are things that to build proper sort of dedicated private networks. And that, of course, from an industry perspective, we always talk about all these sort of technical things like bandwidth, reliability, flexibility, and security. But in reality, when we start looking into the use cases, it's many times about other things that they want out of this. But these are yet enablers, and this is what we'll start with. We'll start with the enablers, and then we'll look at some of the cases that we have done with this to illustrate how you can combine these elements and functions to make something useful out of it. Now, what you see here is a snapshot. It's a snapshot of a subset of the mobile private networking portfolio that we have. As you see, there's many boxes here. Many of them are looking different compared to what we're used to in the public area network that we do. Boxes in the public area network are, most of the time, we try to make it as blend as possible. They should not be an eyesore to things. But here you see a lot of colorful boxes. And this is the effect of having 3GPP then colliding with these vertical industries. So what we see is that even that we build these networks and we make the foundation based on 3GPP and the 5G, we end up with having to work with standards coming from these verticals and blending these products to make sure that they have the right fit, form and function for the projects. So these are not sort of only your standard office stuff that goes in or standard macro base station. These are things that are there for hazardous environments where you have risk of explosion, ruggedized environments, water-filled environments, things like that. And that comes driven out of these industries. We'll have a little bit more look into each of these ones later on and see how they sort of are applied for this. But that's sort of the basis for having a large portfolio, but also, as you see, they are different from the other elements. Now, looking at this from a perspective of where we see our function and what the value that we bring into this. We're a telecom company. We provide equipment for this, so our expertise is in the end-to-end private networking area. But we do need to work with everybody else in the industry as well. We are not the vertical experts. We use system integrators to do that sort of matching of what we do with the real world. There are plenty of experts out there, experts on their specific industry. But what I'm saying here is also that even that is the case, or that localization and that adaptation to the industry, that is not only happening at that interface. We have had to change all our products to meet the industry demands for the specific industries that we are working with. Now, we have a foundation which is very flexible and lightweight. So it's sort of a three-tier architecture which allows us to do very small systems and very large systems and scale from having scenarios with hundreds and hundreds of users. We heard the previous speaker here talk about when many enterprise scenarios are very small in terms of the number of users. That is true for some of them. But I've seen the opposite as well. I've seen some of them that are very, well, maybe huge, but we're looking at some logistics applications with, say, 700 AGVs in one building running around, but consuming very little data in this. But this architecture allows us to work with this and do configuration out of this that is suitable for each and every industry out there. We also see this we have scalable extensions to this. We add things to it as needed. We don't try to force everything into the 5G pocket. And there would be a mistake doing that. Even if 5G has sort of been advertised for a long period of time as, yes, this is a solution to do all these different things. It's not always cost efficient. We'll talk a little bit later about that, especially around sort of positioning and things like that. And of course, there's a whole sort of interfacing towards the world as well, how you interface with all these devices, making the real world digital. We're involved in some of it, but much of it is working with partners in that space as well. So, in summary, we try to create the seamless connectivity, but having it as open as possible to allow these verticals to fit into it. Now, there's a number of different enablers, and I think one of the things that have come in to us quite handily is the cloud piece of it. And we use that for the 5G deployments. Now, 5G cloud allows you to do a number of different things in the MPN scenario. One thing is you can just put it there and of course just run that as the sort of 5G core that you want to have for your network. But it also allows you to do other things, like put some of the very time-critical applications on your site, still using the 5G core, or use it for redundancy. So this is very good for many scenarios, but I must also say that not everything that we do is technically driven. So from a sort of technology standpoint, when we all look at this, we'll probably feel that, yes, of course, this is how it should be done. But I find also cases out there that are driven out of completely different motives in there. And it comes back to simple things as who has the cost centers to deploy this. I have had customers asking for, I want 5G core on every site. Not because they think it's the most efficient, but inside large corporations that would be the perfect one to sort of take on this cloud, they have this separation into cost centers, and which makes it, you drive it for, because that is how that company operates. Now, when we say easily scalable, we of course we mean the 5G network and how we sort of can scale that, but also how we fit in with the other technologies. We don't see, as I said before, 5G is the only way of solving this. To have a few examples on this picture here, maybe a little bit easily deploying this as, okay, manufacturing area, warehouse area, office area, maybe of course be different, but we do see that mixing and matching technologies in these cases do help. So using passive IoT for both location and tracking many things instead of using quite expensive 5G methods. So it's about finding the right combination of this, whether you use sort of 3GPP technology or other technologies that fit with 3GPP technology. And that we do like passive optical LAN as well. We do sort of fit that in to the use cases and the sort of smart business that I have here on the right-hand side, so that we create a concept that works for that specific customer or for that specific industry. I think it was alluded to here before with sort of all of these all-in-one servers, and they are important in this. Not as a sort of functionality perspective, from a functionality perspective, because they do the same thing as you did before, but it has one advantage here. If you go to a large corporation, you can always find money to do all of these different things. So you put your separate core, EMS system, do the application sourcing. But in many cases, you have quite small branch offices and things like that, which means that they can't take all that cost, or the use case doesn't support it. So by packing things and containerizing it and making all these all-in-one services sort of brings down the entry-level cost, and the scalability gets to a much, much lower level. And that allows you then to take on more business cases or more use cases out there. So this has been a fundamental important factor to sort of bring it down to that scale. The other function that is important that I alluded to when when we looked at this 5G core, cloud core function, is that this local breakout turns out to be something important in all cases that really need real-time data. Whether that is that you control things or you're collecting data, that is needed. And of course, if you would have a separate core sitting somewhere else, you always end up with these sort of long latencies, whether it's 100 milliseconds or it's 50. it doesn't matter, it's just too much. So the cases that we've seen as driving this forward, we looked at the mining industry, for instance, I'll come back to that and talk to it a little bit later, the automotive industry, they all want sort of sub 10 millisecond levels on this. And then using the local breakout, local UPF really helps with this and really enables us to do some of those cases. So just try to make it a little bit less complicated, have the data where it's needed. And of course, it also improves, in many cases, the sort of, at least the feeling around security and the data privacy around these applications. Now, back to maybe the little bit more interesting part. What do we do with all this then? So we have a few industries that have been quite big for us. We've done a lot of mining. We've done a lot with the energy sector. We've done some manufacturing, construction industry. The care sector has been quite good as well. And then there's this sort of constant stream of all of these campuses. But if I would sort of pick two that sort of stands out, it's around this mining and the energy sector. So with mining, we developed solutions both for coal mines and metal ore mines. And these solutions are very interesting because they have scale, both in terms of sort of equipment that we ship, but also in terms of machinery and the number of sensors that we work with here. So in these underground mines, there are literally thousands of sensors to monitor water, air quality, all kinds of different things that are important for health and safety in these premises. But also, there's a need to control all this equipment. And it's important to do this in a very safe way. As you probably hear from time to time, you have all these mining accidents and workers come out and things cave in, the machinery is dangerous. And what we try to do, working with these industries, do two things. Improve the efficiency, and the other one is bring down the number of accidents. And for that, we have used a lot of camera technology here to monitor and make sure that everybody in these mines actually adheres to security protocols or safety protocols, making sure that they stay safe and sound and can return back home at the end of the day. So it's simple things like, you shouldn't smoke in a mine, right? You shouldn't gather in big groups. This might seem simple, but you're underground there for 8 hours, 10 hours. It's natural people start sort of missing some of these things and they fall asleep. So they need a nod, right? So this is the type of things that we do with the equipment, making sure that everybody is safe and sound. Another important thing is the sort of the efficiency factor of this. So by remote operating the machinery and making sure that everything is accessible at every time, we've been able to sort of bring out the automation levels to over 90%. So that may say something to you, but it also, what it does is it removes the need for people in the underground environment. So we cut it by 50%. So those two things sort of help each other as well. Yes, we got much better automation, but we also got much less people in the mine. And with having less people in the mine, there's of course fewer people who also get accidents. And we've seen a reduction in these accidents in the mines that we operate in with about 16%, which is sort of a good number for the industry. As I said before, we've also been very successful in the energy sector. It's in a way, it's I wouldn't say like mining, but you will see here this pattern emerging. Both these industries are big on capex investment. They put in a lot of money into what they're doing. They have valuable produce, which generates a big turnover. And that sort of setting makes the industry very good to do, or very subjective to do a successful transformation in. So what we've done here is a sort of a similar thing as with the mines. We try to automate many of the things that they do. And if you look at these power plants, they manage quite either many things like in wind farms, for instance, or in solar farms, or very complicated equipment like in the nuclear environment. And with this, what we've done is we put these systems in and then bring the values out by having efficiency coming out from this, and making sure that things like preventive maintenance can be done in a timely manner, but without causing any accidents or anything that goes wrong with it. So this using the big data together with the equipment or with the 5G network, and then combining it with some of these very hard to do tasks. And if you're in a nuclear plant, you need to go into some of the sort of more difficult areas. So you can have inspection robots, you can have inspection drones flying around, checking things on the thermal plant, for instance. So it's very important. As you see here again, you have now another red piece of box here. And again, it's another industry that needed specific things to operate this. So these peak RAUs that we put in here, they are specifically changed materials in these ones, where you build these radios typically with using aluminum or aluminium, depending on where you come from. You have to switch here to other things. You have lead protection against the radiation. You use copper instead of aluminum to make sure that you have a higher melting point for the equipment, because that's what the industry requires. And it's in here. So you can't just take standard sort of office equipment and put it into these environments. It just doesn't work. Petrochemical, again, is sort of a very similar story with these ones. Also big producer, a lot of capital employed, and also where small changes in your efficiency immediately generates numbers that are interesting. So with this, we sort of build out across these plants. We put in all the equipment that's necessary then to create communication inside the plant, whether it is to monitor different valves or pollution or check for leaks, or work with sort of inspections on these sites. They all require specific equipment again. So in this case, if you were in China, it probably would be MAKA. If you're in Europe or US, it would be ATEX type of equipment that you need, because there's an explosion risk around this. You can't just put in your normal things in this. It does require this. But it also ventures out to doing remote operations. I have one slide later on that remote operations. So it doesn't come, it's not one form that fits all, that it's just you put some centralized baseband and you then put some radios and you're done. You do need this specialized equipment, but you also need these sort of remote islands, locations to sort of pick traffic up where it's actually generated. So, for instance, with these oil producing pumps there. And for that, we do have different solutions. So we use microwave, but we also use sort of standard backhaul using the public networks as well as private. Yeah. And with this, scaling it down to this level allows you to do more things. Well, I talked a little bit about venturing out in this oil industry, taking the individual pumps here, but you have other things, marine aquaculture, for instance, whether you grow fish or seaweed. You need to monitor these fishes. You need to make sure that you feed them properly. You need to make sure that they have no parasites. You need to watch your produce, and once it's ready to harvest, you harvest them. So there you can have a lot of sort of benefits from putting in this 5G technology. But the same type of solution there, we just need to sort of split this off into these small pieces where you where you sort of create your own local network and then sort of bring it back again. Can be used for emergency services vehicles. You have poor coverage, you go out there and then you create your sort of link backwards, and then you create that sort of phone network or handheld network around that area to master situations in where you have an event or an incident. Construction industry also has these sort of short-term temporary solutions that they need. So where they need to put up something rather quickly, then half a year later it's gone, so it's not a permanent thing you install. We have tunnel coverage, for instance, when you build tunnels and you do things, you sort of extend it in before you actually are ready with it. We use 5G for it, but we also use sort of traditional microwave systems and then combine them with the 5G. And this is, again, then to sort of extend the reach of these networks when you build the private networks. So either for, it's in this case, petrochemical oil extractions, I talked about this, how to sort of get data from these wells, but also for other things like fire prevention, forest monitoring, making sure that you monitor so it's not illegal logging, there's no fires coming up, applications like that with this type of solution. We also do traditional things with this. So again, it's sort of same structure of this, but it's a different composition of what we use in these cases. So this is taken out of one manufacturing plant that we've done, where we sort of put in the normal type of equipment that you would see out there. So these are these blend ones, they are meant not to be seen, right? So you put in these radios, whether it's low power radios in the buildings or it's high power radios for outside campus growth or outside campus area. This we found quite good in terms of creating that consistent capacity coverage, because many of these manufacturing areas, they are constantly under change, and what they need is sort of consistent. Wherever you are, you should have 100, 200, 300 meg uplink. It's not necessarily the total one that is big, but everywhere you are, you need to have that to make sure that all these applications that you run actually work with it. So what do we do then? So we use this for indoor positioning. We combine this with either, we looked at this ultra-wideband Bluetooth or passive IoT to work with that, but also for ATV navigation. Now this is not normally a very sort of consuming in terms of bandwidth, it's just you need to have communication with these ones. But we use it also for some of the safety security in these environments. So we connect our cameras up to the 5G system, we do automatic facial recognition to make sure that the environment is secure, that we have no elements running around that shouldn't be there. And they're also safe, making sure that you need to have training where you actually are. You can't move around with industrial robots if you don't have the training. Automatic optical recognitions, machine vision, doing quality audits around this. So that's type of things. So as you've seen here, what we have done, if I try to sort of summarize this, we've been able to scale a number of different industries. Both sort of very big ones and very small ones, yet keeping to the same system, yet keeping to the same components, and then just mixing and matching to make sure it works properly.
Okay, thank you. Thank you. Yeah.
Did I overcost in time?
Not too bad. Not too bad. It's hard to say.